Now, last lesson video we dealt on sine rule, and we'll come to a conclusion that if you have a triangle that is not right angle triangle ABC with length AB and C, we'll say that A divided by sine of A is equals to B divided by sine of B, which is equals to C divided by sine of angle C. This is for sine rule. Now, just as we have sine rule, we also have cosine rule. So let's take a look at cosine rule now. Let's try and derive it just as we derived in sine rule. Remember, we are considering a triangle ABC with length A, with length B, and with length C. And just like we did in sine rule, there was a perpendicular bisector at point A. This bisector gave us a height of h. Now, considering that the length from B to C is equals to A, with the introduction of the perpendicular bisector, let's call this point D, and point D to C, let's call it X. So definitely the remaining point B to D, this length, it will be A minus X. So we are going to consider two triangles. Let's consider triangle ADB, which is right angled at D. Triangle ADB is like this, right angled at D, with height of h, hypotenuse of C, and the adjacent A minus X. And likewise triangle ADC, which is right angled at D, as an hypotenuse of B, a height of h, and an adjacent of X. Now let's call this angle C because it is at point C. Now with angle C, now from this triangle we can introduce cosine. Introducing cosine, so we are saying that cos C is equals to, remember from SOHCAHTOA, which is very important in trigonometry, cos is equals to adjacent divided by hypotenuse, and the adjacent in this case is X, the hypotenuse is B. So Fx is equals to B cos C. Now if you come back to triangle ADB, which is right angled at D, we can have an expression for the hypotenuse of Pythagoras theorem. In Pythagoras theorem, we have the hypotenuse squared is equals to the opposite squared plus adjacent squared. So the hypotenuse in this case is C squared. The opposite in this case, let's call it h, as the case may be, h squared. And the adjacent in this case, we call it A minus X squared. So moving on, we have 6 squared is equals to h squared. If we open this bracket, we will have a squared minus 2ax plus x squared. Definitely we have c squared is equals to h squared plus x squared, let's say minus 2ax plus, let's do it, write all the squares together, plus a squared minus 2ax. Now if you come back to triangle ADC, if you apply the Pythagoras theorem here of hypotenuse squared is equals to opposite squared plus adjacent squared, the hypotenuse in this case is B, so we have B squared is equals to the opposite squared, the opposite is h squared, and the adjacent is x squared. Now we can see the expression of b squared is equals to 8 squared plus x squared. So we can make the substitution here. Therefore, we'll continue here and say c squared is equals to b squared plus a squared minus 2ax. Now let's rearrange. So we have c squared is equals to a squared plus b squared minus 2ax. If you come back again to triangle ADC, we have an expression of x, that x is equals to b cos c. Now if you make that substitution to x, you will have that c squared is equals to x squared plus b squared minus 2ab cos c. Now this is an expression for cosine law or cosine rule. Similarly, now let's draw an inference, okay, just like we did in sine law. That if we have a triangle, could be scaling, could be isosceles, could be equilateral, but it is not right angled. So we have triangle ABC with length A, B, and C. We can arrive at c squared, just as we arrived. C squared is equals to a squared plus b squared minus 2ab cos c. Similarly, we can find the expression of b squared and a squared. Yes, you guessed right. So b squared will be equals to a squared plus c squared minus 2ac cos b, and a squared will be equals to b squared plus c squared minus 2bc cos a. Now this is what we tag as cosine rule, which is applicable when we have two sides and one included angle. So we have two sides and one included angle. Two sides AC, one included angle. Two sides BC, one included angle A. So this is cosine law. Let's write it. Two sides and one included angle. Now let's take a quick example on cosine law. Let's say we are given the triangle ABC. We're given the length of A to be equals to 3 centimeters, the length of B to be equals to 2 centimeters, the length of C to be x centimeters, with the angle of C to be equals to 80 degrees. And we are asked to find x, or let's just call it C centimeters. So with this now, we understand from cosine law or cosine rule that c squared is equals to a squared plus b squared plus 2ab minus 2ab cos c. So if we implement this now, we can simplify the value of c, because we have a to be equals to 3 as we have in the question. Likewise, we have b to be equals to 2 given in the question, and the angle C to be equals to 80 degrees, which is seen in the diagram. So let's find the value of C. Therefore, C squared is equals to 2 squared, no, 3 squared plus 2 squared minus 2 into 3 multiplied by 2 cos 80 degrees. So let's use our calculator to simplify this for ease. So 3 squared will give us 9, 2 squared is 4, 2 by 3, 6 multiplied by 2, 12, and then cos 80 degrees is given as 0.1736. And using our calculator to simplify this, we will have a final answer of 10.916 to be equals to c squared. So to find the value of c now, we'll have to take the square root of 10.196, which is equals to the square root of this answer is equals to 3.304 centimeters, which is approximately 3.3 centimeters. Yeah, you might be asking, why can't we just solve this using sine rule? Yes, so can we actually solve it using sine rule? Let's look at it. Remember, it's the rule of sine. A divided by sine A is equals to B divided by sine B is equals to C divided by sine C. What do we have? What are we looking for? We have A to be equals to 3 centimeters. We have B to be equals to 2 centimeters. And then we have angle C to be equals to 80 centimeters. We are looking for this. The question is, we need a complete section in case we want to solve this. And of course, this is not a right angle triangle. We could have just applied Pythagoras theorem to evaluate C. So it doesn't work. We don't have angle B. Likewise, we don't have angle A. So the only solution is to use the cosine law. Let's take another example. Question 2. We're given a diagram just as similar as the previous one. Now we are asked to evaluate lengthwise centimeters, given 5 centimeters and 3 centimeters with angles 102 degree. So let's try and label the triangle. Let's call this A, B, and C. So in essence, we are saying B is equals to 3 centimeters, C is equals to 5 centimeters, angle A is equals to 102 degrees, and we are asked to look for A. So let's recall the laws in cosine rule. We have c squared is equals to a squared plus b squared minus 2ab cos c. Likewise, we have b squared is equals to a squared plus c squared minus 2ac cos b, and a squared is equals to b squared plus c squared minus 2bc cos a. So moving on, we want to evaluate A, and then we can see that we have the value of B given in the question to be 3 centimeters. We have the value of C given in the diagram as 5 centimeters, and we have angle A given in the question to be 102 degrees. So let's begin. Let's apply the law. A squared is equals to b squared plus c squared minus 2bc cos a. Definitely we are looking, A is equals to y. We are looking for y. Okay, A we are looking for is y centimeters. Our B is 3 squared and our C is 5 squared minus 2 into 3 into 5 cosine 102 degrees. So let's simplify further. 3 squared is 9, 5 squared is 25, and this would give us 9 by 6 by 5, which is 30, cos 102 degrees. Now I want to simplify cos 102 degrees, and this brings us back again to the quadrant. 102 degrees is in the second quadrant, and let's just reflect back to the second quadrant. Second quadrant is such that the angle theta is greater than 90 degrees but less than 108 degrees. Sorry, 180 degrees. And in the second quadrant, we have that only sine is positive, all others are negative. So we are saying that sine theta is equals to positive sine 180 minus theta, because 180 minus theta is the relative angle formula. This we dealt intensively in our first set of videos. Similarly, let's evaluate for cos theta is going to be negative cos 180 minus theta, and tan theta will be negative tan 180 minus theta. So moving on, we'll make the solution for cos 102 degrees, and this time around we'll be applying what we have here. Therefore, we will have 9 plus 25 will give us 34 minus 30, and cos 102 degrees will be simplified to 108, or cos 102 will be simplified as a negative cos 180 minus 102 degrees, because theta is 102 and we have our answer to be in negative term. So this will give us 34 minus 30 into minus cos 180 minus 102 degrees is 78 degrees. So simplifying negative, we multiply negative, and we would have 34 plus 30 cos 78 degrees. Cos 78 degrees using our calculator is going to give us 0.2079. Simplifying further, and we will have our answer of y. Okay, this is y squared. We'll have our y squared to give us 40.237. So simplifying further, then we can have our y to give us the square root of 40.237, and we'll have our answer of y to give us 6.34 centimeters. So we have seen how to apply the law. We also saw how to derive the law. Let's take more examples on cosine law or cosine rule to establish understanding.